you in SST College of Arts and Commerce. This is SST Edupedia. Myself Rubini Daniel. Today we are going to see about the topic graph. Subject Fundamental of Algorithm, class second year BSc Computer Science, semester 4, topic graph. In today's class we are going to discuss about graph and types of graph and graph representation. In previous video we have already discussed about tree, binary search tree. Today this topic graph is a very interesting topic we are going to discuss. First we want to see what is a graph. A graph, it is a data structure that consists of a set of nodes that is called vertices and set of edges that relate the nodes to each other. So in the graph we are going to talk about the edges and vertices. The set of edges describes relationship among the vertices. So what is edge? It describes the relationship among the vertices. So a graph G is defined the following: G equal to V comma E, where V denotes vertices, E denotes edges. So V of G, a finite non-empty set of vertices, E of G, a set of edges, a pairs of vertices. So this is the graph. Like this only we will be representing the graph. Here you can see A, B, C, D, E. That is called vertices, edges A, B, B, E, D, E, C, D, A, C. That is called edges. So in this diagram we have learned what is vertices and what is edges. See here another picture representation to learn what is edges. AC, AB, AE, AF, DF, CD, all these are edges. That means the edges, the connection between the two vertices, the path between the two vertices. Here we have learned many edges: E1, E0, E2, E3, E4. So 4 edges has been used in this graph. Now we are going to see the two types of graph, that is directed graph and undirected graph. Undirected graph, that is undirected edge has no orientation, no arrowhead. So in undirectional graph there is no edge. It will not have any edge. So undirected graph edge has no orientation. No orientation means no arrowheads. It will not have any direction. That is called undirected edge. And secondly, directed edge. Direction means it will show the direction. So it will have the orientation, that is arrowhead. So for example, in the directed graph, what will be there? Arrow point or arrow mark will be there, or arrow head will be there. It will be showing the direction. Whereas in undirected graph there won't be arrow head. It will not show any direction. So undirected graph, all edges are undirected. There is no any direction. Directed graph means all the edges are directed. So undirected graph and directed graph. So you can see here undirected graph and directed graph. You can see the differences. In undirected graph there is no arrow head. In directed graph you can see the arrow head. So V1 is connected to the V2, V2 is connected to the V3. But here you can see there is no arrow point. That means there is no any directional. But directed graph, it is showing the direction. That is the difference between the undirected graph and directed graph. So undirected graph, directed edge. So directed edge, that means I comma j is the incident to the vertex j and incident from vertex I. So vertex j is the adjacent to the vertex I. Adjacent means you can see the next vertex. So vertex I is adjacent to vertex j. Same like that, vertex j is adjacent to the vertex I. So now we are going to see a main important thing, that is a graph terminology, adjacent nodes. Two nodes are adjacent if they are connected by an edge. When we can say it is an adjacent node, when the two nodes are adjacent if they are connected by an edge. Path. Path means what? A sequence of vertices that connects two nodes in a graph. A sequence of vertices. There is a sequence of vertices are there. It has been connected. Okay, two nodes in a graph. In a path, we are having difference. That is a simple path. A simple path is a path in which all the vertices except possibly in the first and last are different. Then we are having a different type, that is a complete graph. A graph in which every vertex is directly connected to every other vertexes. So complete graph means a graph in which each and every vertex is directly connected to every other vertexes. So every vertex is directly connected to the every other vertexes. That is called complete graph. Now undirected graphs. In undirected graphs also some types are there. Undirected graphs, connected, strongly connected graph, weakly connected graph, complete graph. So in undirected graphs are connected if there is a path between any two vertices. When we can say it is a connected graph, when the undirected graphs are connected if there is a path between any two vertices, that is called undirected graph. Directed graph. When we can say directed graph, directed graphs are strongly connected. We can say it is a strongly connected if there is a path from any one vertex to the another vertex. We can say directed graph is a strongly connected graph. When we can say if a path is from one vertex to the another vertex. Directed graphs are weakly connected. We can say directed graphs are weakly connected because there is a path between any two vertices ignoring the direction. So here we need to include the direction. Directed graphs are weakly connected. So if there is path between any two vertices ignoring the direction. So in the directed graphs there is a two types. One is a strongly connected and another one is weakly connected. Now next one is a complete graph as an edge between every pair of vertices. So every pair of vertices may edges will be there. That is called complete graph. So again we are going to see loops. Graph terminology we are going to see about the loops. Loops, that is nothing but it is an edge that connect a vertex to itself. It connect a vertex to itself. That is called loop. So edges that connect to a vertex to itself, that is called loop. Then path. Path means sequence of vertices, that is called path, where each adjacent pair of vertices are connected by an edge. Then simple path. A simple path is a path in which all the vertices except possibly the first and last are different. So first and the last vertices are different. Multiple edges. So two nodes may be connected by greater than one edge. So multiple edges means two nodes should be connected by greater than one edge. That is called multiple edge. Simple graph have no loop. Simple graph means it will not have any loop at all and no multiple edges. So what is a simple graph? It will not have any loop and no multiple edges. So how we can represent the graph? For graph to be computationally useful, they have to be conventionally represented on program. So we can represent the graph in two ways. One is adjacency matrix representation. Another one is adjacency list representation. Adjacency matrix. Everyone know matrix. So we are going to see how the graph is going to represent in the adjacency matrix. A square grid of Boolean values. If the graph contains n vertices, then grid contains n rows and n columns. So we are going to see about the adjacency matrix. See, this is adjacency matrix. In my graph, I am having the vertices 1, 2, 3, 4, 5. Now I am representing my graph in the form of matrix. So here 1 is 1 to 1, 1 is 0. Then 1 is 2. Yes, 1 to 2 is connected. So we are having 1. Then again 1 is connected to the 3. One edge is there. So I am writing 1. So 4. 1 and 4, yes, 1 and 4 is connected. So I am writing 1 and 1 and 5, there is no edges, there is no edge or there is no connection between 1 and 5, so 0. Like this you want to represent the adjacency matrix for the graph. Same like that for 2. See, for the 2, 2 is, yes, 2 is connected to the 1. So 2, 1. So I am writing 1. Again 2 and 2. 2 and 2, there is no self loop. So 0. And 2 is connected with 3. No. For between 2 and 3, there is no connection. So 0. 2 and 4. Yes. 2 and 4, there is a connection. So 1. Then 2 and 5. 2 and 5, there is no connection, 0. Like this you want to write for each and every vertices 1, 2, 3, 4 and 5. So like that you can represent the graph in the form of adjacency matrix. Now we know already a graph can be represented in the form of adjacency matrix. Another one is adjacency list. Now we learnt about the adjacency matrix. Now we are going to see about the adjacency list representation. A graph of n node is represented by one dimensional array. You can represent in the form of one dimensional array, that is the linked list containing all the nodes adjacent from node I. The nodes in the list L of I are in a no particular order. So we can represent the graph in the form of adjacency list. So here the graph is having the vertices 1, 2, 3, 4. 1 is connected to the 2, 2 is connected to the 3, 3 is connected, 1 is connected to the 3, 4 is connected to the 3. There is no connection between 1 and 4. So this graph you can represent in the list, adjacency list. You can see here also graph is the A to B, A to D, B to C. So this graph we are going to represent in the list. So now the graph A, that is B. So A is connected to the B. Again that B is connected to the C. Like this we can write the, we can graph, we can represent into the list, that is the another one you can see C. C is connected to the B. So like this we can represent the graph into the adjacency matrix. So adjacency matrix and adjacency list, these are the two representation for the graph. Okay, in this class we have learnt about the graph, types of graph and graph representation, that is adjacency list, then adjacency matrix. This is for the today's class. Thank you.